Good morning, students. In last session, we complete in second and first topic called database design. That is how we design the database. Okay, which consists of 6-step process. Now I want to start a new topic called as ER model. So what is ER model? Okay. Uh, so what is ER model and what is entity and what is attributes and what is entity set and what is relationship and what are various types in it. Okay. So this is the topic what we are discussing now in this session. Okay. So before start this ER model, what is the necessity to design ER model? Okay, right. See, this is if we have a group of keyboards that are from the same company, same color, same look, then we can't differentiate between them just by seeing them. So we have a group of keyboards. In that keyboards, all keyboards are belongs to same company and all look same color and same design. Okay, so how we differentiate one keyboard with another keyboard? Okay, so now the problem is, this is the problem. So we can differentiate with some solution, that is if we know the product number which is unique for every keyboard. So for each and every keyboard there has a some unique number. So based on that unique number, we can distinguish one keyboard with another keyboard. So if we don't know this product number, then these keyboards can't be identified from, and they are just objects. So similarly, in real world, in DBMS, we have various relations, nothing but various objects. If there is a distinguish from one object to another object, it has same problem. That is, all will be same. So when all will be same means there is a very problem to construct the database schema. So to easily design the distinguish from one object to another object, we use a model called as ER model. Simply, we have the history. So the history of ER model is, so ER diagram is a visual tool, that is a picture representation which is helpful to represent the ER model. So already we discussed that ER model consists of a picture representation. Okay, so it was proposed by Peter Chen in 1971 to create a uniform convention which can be used for relational database and network. So already we discussed that we design the database schema by means of what we call tables. So instead of directly writing the tables, you take the design called as ER model. Based on ER model, you are converting that model into your database schema. Okay, he aimed to use an ER model as a, that we call as a conceptual modeling approach. Okay, so ER, this is the example, this is the definition for ER model. The ER model defines the conceptual view of database. It works around real world entities and the associations among them. So it is nothing but ER model is a real world thing. It is a real world thing and association between the real world things. So at view level, the ER model is considered a good option for designing databases. So if the ER model is good, automatically we design a good database. Okay, and ER model is a design or blueprint of a database that can later be implemented as a database. Okay, based on we convert that ER model into database. The main components of ER model are, we have the various components for designing ER model. Those are entities, attributes, entity set, and relationship set. Okay, so if we take a real world scenario called as college is an entity set. We can define college is an entity set. Among the college, we have an entity called as professor, student, course. So for every one real world thing, there are some properties. Okay. So a real world thing that has a properties is called as entity. The collection of all these entities are called as entity set. Clear? Okay. College is an entity set which consists of following entities. Those entities are called as professor, students, course. So these three are comes under college. Okay, so entity set is a collection of similar entities. So that is, this is a similar to college, this is similar to this one, courses is similar to college. Okay, if I say playing, okay, playing comes under college. Okay, so all these entities have some attributes or properties that given them their entities. Okay, already you said that for every entity they have a properties. An entity which has a properties considered as an entity, the group of all the entities are considered as a entity set. Okay, so entities which has attributes can be considered as properties describing it. For example, for a professor entity, the attributes are his name, his address, and his salary. So the attribute value gets stored in the database. Okay, already we discussed. Now, this is an entity. Okay, we represent the entity in rectangle. So, a man, a person is an entity. A car is an entity because man properties means which color he is, which name he is, which gender he is, which address he is living. Okay, all comes under which phone number he is maintaining. So all comes under this particular person. If you take the car properties are car color, car engine, car capacity. Okay, all comes under the car properties. Okay, so person, place, object, event or concept about which data is maintained is a entity. We have example called as car and student. If you take an attribute name, already I am saying that property or characteristics of an entities, which it represents. Example, color of car entity is an attribute. Name of student entity is an attribute. Okay, this is the represent. Color of car entity is an attribute. Name of student entity is an attribute. Okay, now if you matching this car with mapping the car with person, so this which car he is maintaining means that he is maintained by a relation which represent as diamond. The representation of the relation is diamond. The representation of entity is rectangle. The representation of attribute is ellipse. Okay, so the association between the instances of one or more entities, association between instances at a time we are retrieving the data, is called as more entity types. For example, blue car belongs to student Jack. Blue car belongs to student Jack. Okay, I hope you are understanding. So next, now we are moving to simple, starting with example called a simple ER diagram. So in the following, this is a ER diagram. In the following diagram, we have two entities called, this is student and this is college, and a relationship by means of studying. Studying is an instance. Okay, student studies in college, relation. Yeah, I want a student studies in a college. This is a relation. Oh, studying is an instance. Okay, relationship is nothing but the name of a relationship is an instance simply. Okay, next, the relationship between student and college is many to one. Already we studied that we have four mapping constraints called as 1 to 1 1 1. Next, 1 to 1, 1 to many, many to 1, and many to many. Now this is the relation between student and college, that is many to 1. As a college can have, college we have many students. However, a student cannot study in multiple colleges. Okay, he will study in a particular college. Now all college consist of more number of students, and student enters into particular college, not two or more colleges at the same time. So student entity has attributes ID, name, and address. ID, name as the attributes of college. I hope you are understanding. Now see, in previous class, we defined the layers of abstraction, conceptual, logical, physical. Already you understand the previous class, but so many have some doubt. That is, in conceptual means you are designing your diagram, sir, so that automatically we can see, sir. So why you are saying that is an abstraction? Okay. See, this is a important. I have a student. I have a student ID. Okay. I have 5 students in the particular student entity. Is it visible to you? See, here student, here we have 5 students. So all 5 students are in particular entity. Is it visible to you? No. If it has 100 students, is it visible to you? No. Means this is nothing but layers of abstraction. We are showing the what we call useful information. The useful information is stuff student and his properties. Not how many students are involved in particular student is we can't get. So that is cause nothing but abstraction. So that is the third conceptual. Here I want to give the clarification. How many students are available in this entity means we can't see. But we have a student important hiding the unnecessary information and giving the only useful information. That information is some matching the objects. In ER diagram, we design matching the different objects in a relationship. Okay. So this is the topic we completed. Okay. Next. See, we have entities can be divided into 2 categories. That is tangible entity and intangible entity. So tangible entity means that exists in the real world. For example, if you take a person, for example, if you take a car, these are belongs to real world. Physically, we see the real world in the real world. So physically, we see the particular entity in a real world. That is called as tangible entity. Okay. If physically we appear the data, but logically what we can't see, that is called as particular entity, but we can't touch that particular entity is called as intangible entity. For example, tangible entity, a person, you can see the particular person and you can touch the particular person. Whereas in intangible entity means if you see the particular entity, but we can't touch particular entity. For example, if you take a bank account or email account, logically it not happen. Okay, where physical entity exists in the world, logical, see, simply we say that tangible entity is one which physically exists in the world, whereas intangible entity means which exists logically in real world. Okay, already we discussed. Here we have a person, we have a bank account. Okay, right. So to design the ER model, we have various shapes, various representations. So all we will see here. See, this is for representing entity. We represent that entity in rectangle. To represent attribute, we use ellipse. To represent relationship, we use diamond. If you link between one entity to another entity, we use link, a line. See, if we have multi-value attributes, or we will discuss that. If we have a multi-value attribute, that is nothing but we will see. If the property of deriving an attribute into dividing attribute. For example, if I say the address is a multi-value attribute because based on that attribute, you divide as the properties like door number, area, street. So an attribute which is furtherly decomposed, particular attribute is called as multiple attribute. Okay, this can be represented as double ellipse. Next, derived attributes. Derived attributes means it takes the information from, it doesn't have any information, but takes the information from previous attribute. That is called as derived attributes. We will discuss all these things. Next, total participation is represented as double lines. Weak entity represented by two rectangles. Weak relationship represented as two. Total participation, two bars. Weak entity, two rectangles. Weak relationship, two diamonds. Next, composite attributes. Already we discussed that one. Composite attributes which can be derived. Next, key attribute. Key attribute is nothing but based on particular attribute we can return the data. For example, if I say your ID, okay, your roll number. Based on roll number, I can define your name, okay, your address and your backlogs and your meritorious result. All will be, I will be returned based upon particular key attribute. Okay, so we will discuss. See, this is the if it is a link between one to other, we represent as already we mapping constraints. See, this is one to one. We represent as one to one. It is one to many should be represented as like this. Arrow symbol. Okay. Next, many to many. Okay. If it is many to one means here the arrow comes. Here the one means there will not be any arrow between this one. Okay. Optional. There should be a link. It is optional means we represented by means of a dashed line. Okay. Next. See, entity type, already we discussed this one. Entity type is a set of collection of similar entities. Okay, the entity types is a collection of entity having similar attributes. For in above student table example, we have each row an entity and they are having some attributes. That is, each row has its own value for attributes: roll number, age, student name and mobile number. So we can define the student, we can define the above student table as entity type because it is a collection of entities having the same attributes. Okay, here we discuss this is an entity. This is an entity. Collection of similar entity. Collection of similar entities is nothing but entity type. Okay, see next. In another relation, we have the professor. Okay, professor has a relation. In that you have the 4 rows. So all these rows belongs to in relation table also. Okay, that professor is also called as entity type. Okay, so entity type. Okay, I know you understand the entities, entity type. Now we have go for the attributes. So what do you mean by attributes? Means which represent by means of their properties called as attributes. So for example, a student entity may have name, class and age as attributes. So there exists a domain or range of values that can be assigned to attributes. So the domain or range means, for example, a student name cannot be a numeric value. So if you represent particular attribute, we have some constraint. That constraint is if you represent as an attribute, whether it should be either numeric value or combination of varchar values. Okay, it has to be alphabetic. So a student's age cannot be negative. Okay, so if you take the age as a particular attribute, we don't represent that value as a negative value. If you take the name value, it should not be given as a numeric value. Okay, I hope you understand. So for representation of these attributes, we have 5 attributes called as simple attribute, composite attribute, derived attribute, single value attribute or multi-value attribute. Okay, right. We will discuss these types. First one is key attribute. Already we discussed this one. Key attribute. Simple attribute is also called as key attribute. Oh, sorry. Simple attribute is differentiated with key attribute. Key attribute is nothing but atomic value. Okay. Simple attribute should be duplicate value. Okay. So we will discuss. A key attribute can uniquely identify an entity from an entity set. So this is a entity. So this is a attribute. This is an entity. Entity have various attributes. These called as attributes. So for an entity, for an attribute, if there is uniquely identified attribute is available, that uniquely identified attribute is called as key attribute. Okay, see this one. This is key attribute. So we represent this one as a key attribute. Okay, similarly, this is an entity. we have 4 attributes. Among 4 attributes, this is a key attribute. Similarly, for this entity, we have 3 attributes. Among these 3 attributes, this is a key attribute. Key attribute means uniquely attribute. Based upon unique attribute, you derive the remaining attribute information. Okay. Next, composite attribute. So composite attribute is nothing but based upon particular attribute you have, it should be again dividable. An attribute which is again dividable based upon particular property, that attribute is called as composite attribute. So we have see this one. This is a combination of other attribute is known as composite attribute. For example, in student entity, student address is a composite attribute because as an address is composed of other attributes such as pin, code, state, and country. Okay. Next, go for this one, multi-valued attribute. An attribute that can hold multiple values is known as multi-valued attributes. It stores multiple values. It is represented by double vowels. It is an AR diagram. For example, a person can have more than one phone numbers. So the phone number attribute is a multi-valued attribute. So I hope you understand. Multi-valued attribute means it holds more values. So it holding of more values is nothing but multi-valued attributes. Composite attribute is nothing but that attribute can be divided into further attributes. I hope you are understanding. Address is an attribute. Based on this address attribute, we dividing remaining attributes. Dividing one attribute to more attributes is nothing but composite attributes. One attribute consists of multiple values that called as a multi-valued attributes. Okay. Derived attributes. So derived attribute is one whose value is dynamic and derived from other attribute. It is represented by dashed over. For example, person age is a derived attribute because we can say if you know the date of birth, automatically you can identify his age. So that based upon the date of birth, you are deriving the age. If there is no age means there will be no part of age, because if you say the date of birth of X person, automatically you can say the age of that X person. Okay, it is a derived attribute. So this is the all attributes that comes under the entity called as student. It has a unique value called as roll number, and this is called as key attribute, which consists of various attributes. Among the various attributes, address is a composite attribute. So address is a composite attribute because it divides the more based on this attribute. There will be chances of dividing more attributes. Next, this is a multi-valued attribute, and this is a derived attribute. Okay. Next, if you see remaining single value attribute is nothing but key attribute. You are understanding? Single value attribute is a key attribute. Okay. Next, multi-value attributes already discussed. Simple attribute, it should be atomic, which cannot be divided further. A student phone number is atomic value. So here see this one, name is a multi-valued attribute because it has a possibility of middle name, first name, last name. Address is a, but age should not be full divided. Okay, so it has age. Roll number, it has a roll number. So simple attribute is also called as key attribute, but either in simple attribute means it should not be dividable. Key attribute also be, it should not be dividable. Okay. Next, coming to this model, it is a ER model which consists of entity, attribute, and relationship. This is called as a weak entity. They have a key entity, which attributes called as key attribute, composite attributes, multi-valued attributes, and derived attributes. And if you next class we will discuss the relationship. In that we have the 4 called one-to-one, one-to-many, many-to-one, and many-to-many. Okay. See next, facts about ER diagram model. So why if you design the ER model, what will happen means ER model allows you to draw database design, as you know that. So it is an easy to use graphical tool for modeling the data. Next, widely used in database design. It It is a graphical user interface representation of logical structure of a database. It helps you to identify the entities which exist in a system and relationship between those entities. So all will be facts. So if you design the database design based upon ER model, automatically it represents guy representation of logical structure. Next, it is very easy to understand because it is in a picture presentation. So it identifies whether it is an entity, which entity is participating in a relationship. Okay. Next, why we have to use ER diagrams? So it helps you to define terms related to entity relationship model. See, it provides a preview of how all your tables should connect. Okay, so tables how it should be connected means if the relationship between one entity means another entity, now you connect the two entities with a table, with two tables. Okay, what fields are going to be on each table. It helps to describe which is entity, which is attributes, and which is relationship. So these are translatable into relational tables, which allows you to build database. Okay, already you know. So it can be used by database designers as a blueprint for implementing data in specific software applications. Next, it gains a better understanding of information to be contained in database with the help of diagrams, and it is used to communicate with the logical structure of the database. All should be same. Okay. See, we have two types of entity types called as strong entity and weak entity. So this we will see. So strong entity means an entity which holds the prime, that called the key attribute. An entity which holds the key attribute, that entity is called as strong entity. Okay, if there is no particular key attribute in an entity, that is called as weak entity. Okay, you see, this is a entity which have a key attribute, so this is a strong entity type. Okay, see, this is an entity which doesn't have key attribute, that is there is no dash particular to any attribute, so this is a weak entity. Okay, this is a weak entity because so weak entity can be represented me two double rectangles. So if any weak entity available in your relation, that acts as a weak relationship. So because there is two entities which has two key attribute, this is a strong relationship and strong entities. Okay, if one entity is a strong, one entity is a weak, so this is a weak relation, so that in weak relation, so that the relationship is also a weak. Okay, I hope you understand it. See, this is one. See how this can be explained. ATM consists of ATM ID, address, time. ATM ID. Okay, clear? ATM ID means a unique number. So transactions consist of transaction number, amount, and time. Clear? Transaction number is also unique. But when the transaction number happens means when you take the particular transaction from the ATM, automatically it generates the transaction number. So this entity or this attribute is this entity or this attributes are depending on this attribute. So that this is a strong entity, this is a weak entity. So this weak entity depends on this strong entity. So this relation is a weak relation. I hope you understand what is entity, what are various attributes, and what is entity and entity set. Next, how you represent the entities, and what do you mean by weak entity and strong entity. So in next class we discuss what is relationship and various types. Okay, thank you all.